Yeah, so remember I said that we're gonna be doing questions here. So if you guys want me to focus on certain questions, you can also specify, since we have today and tomorrow only to do questions. So now the questions that I want us to focus on are based on, we're gonna start with the ones which we I think we did yesterday, and I said that we're gonna do a power series representation, some questions there. So I'm gonna re-explain them here. I'm gonna re-explain them. Yeah, the session is being recorded. So the first question here, okay, they say we should. The first question they say that we should say that write the given function. Should write the given function as a power series. This is just saying to put this into a power series representation, right? And give the interval of convergence. You see, right? So the first question that we have is as follows. The first question is that we're given f of x, which is equal to 6 over 1 plus 7x to the 4. You see, right? And solving this would have to drop the 6. We have 1 plus 7x to the 4. So the idea for this is to change this into this format, to put this into this format. You see, right? So that it can be easy for us, provided that this converges when the absolute value of x is less than 0. You see, right? So it's to put that into that format. So we need 1 on top, that's why we drop the 6, and we need minus here. Right, so this one can be anything. This value can be anything. This variable can be anything. So here we're going to have 6, 1 over 1 minus 7 x to the 4. You see, right? Which means that now this is in the format of the summation of that from 0. Don't forget this one is equal to the summation of infinity and equals to 0 of x to the n. You see, right? So even this one, where we see x, we're gonna plug that. So we're going to plug minus 7 x to the 4 to the n. We see, right? So now we're getting this to our representation. I'm sure we agree with this. So it means that this would be equal to 6. Should be equal to 6, the summation infinity, and equals to 0. And then we have minus 7 x to the 4 to the n. You see, right? So provided here, this will be provided that the summation, the absolute value of minus 7x to the 4 will be less than 1. So it means that this will converge for this. You see, right? So I'm sure this simplifies the question where we were able to put it into the power series representation. Now the second question says that we should give the interval of convergence, right? So for us to give the interval of convergence, we just need to take this. For the interval of convergence, we just need to take this and say that now, since we're given this x to the 4 less than 1, this will imply that we're going to take out 7 as positive. We'll have x to the 4 less than 1, and this would imply that we divide both sides by 7. We can have this 4 outside, it's allowed by the rules, 1 over 7, and now we have to fourth root both sides. We're going to have the absolute value of x, which will be less than 1 over the fourth root of 7. You see, right? Now this will be our interval. This will be our radius of convergence. This is the radius of convergence. Now don't forget, we're looking for the interval of convergence. Now this will imply that minus 1 over fourth root of 7 will be less than x less than 1 over fourth root of 7. Now we noted that we have put this into this format, right? And in this case, I'm going to show you this. There's some things they're going to be wasting your time. Right? In this case, we don't need to check the endpoints, right, of the interval. Reason being is because we're able to change this equation into this format. So whenever you can change it to this format, just know that whatever interval you get, that will be your interval of convergence. You see, right? So it means that the final solution will be for the power series. Maria, I think, let me just underline them. Then I can say that the interval of convergence will be you see, that is the interval of convergence. Then we are good to go. Now, if you have any question, please make sure you open your mic, because I can't see the chat box. So make sure you open your mic. Now,
why are you saying this is our interval of convergence without plugging it onto the original origin?
It's because once you are able to change this interval, this function to this format, then your interval of convergence will always remain the same as the interval of validity.
Okay, thanks.
Yeah, so yeah, that will always be the case. You will see for all problems, you can always confirm for all problems here. So now we come to the second one. We have say f of x, unless if check now. You see, if they give you these are two different things. If they give you this and they say check the interval of convergence, then you have to show the endpoints. You have to check the endpoints. You see, right? If they give you this, they give you a power series. But if they give you a function and you change it to this format, then you don't have to check the endpoints. You see, right? But yeah, so as much as you're doing this now, I can give you tomorrow to go consult with the lecturer. Unless if they prefer that you check, but always the interval will always remain the same. Even if we check, it's just going to waste our time. You see, right? So for safety, you can just check tomorrow with the lecturer and see if they allow you to not check or not. So now we have this. Now the aim again here is to change this to what? To 1 over 1 minus x, provided that absolute value of x is less than 1. So if we check, we need 1 on top, right? So we can easily drop that x to the third. 1 over 3 minus x squared. Here we need minus, it's correct. This one is fine. We don't have to change it. Here we need 1, so we must factor out that. We're going to have x to the third. Here we can factor out that 3. 1 minus x squared over 3. You see, right? So that is the case. Now we are able to change this to that format. We can take out 1 over 3. We can take out 1 over 3. Then we're left with 1 over 1 minus x squared over 3. You see, right? Then check this inside. Check this inside. It's in this format. You see, right? So it means that that can be written as x to the third over 3, the summation infinity, and this will be the summation of infinity n equals to 0 of x squared over 3 to the n. I'm sure we see this. Now, if we have this, we can say provided. After plugging it, you must say provided absolute value of x squared over 3 will be less than 1. You say, right? And then I can just go ahead and simplify this. Put this into that format. So this can be like this, 3 over 3 to the n. Yeah, it can be something like this. Is it fine? No, there's 3 to the n plus 1. There's this one. So if I take this, okay, let me maybe do it step by step. So first I start by changing that to this. And then this will be equal to you see, right? Then this is our equation. Then if we check for the interval of convergence, we can just take this and have we have that the absolute value of x squared over 3 less than 1 will imply that minus 1, not minus 1, will imply that the absolute value of squared will be less than 3, and this will imply that minus 3, not minus 3, but it's fine, not minus 3, absolute value of x is less than root of 3. This will imply that minus root of 3. So you should first put this into x only before you can separate them. It's fine this way. You see, right? Then this will be our interval of convergence because we managed to put that into that format. So this is the interval of convergence. You see, right? Any question?
So can you please go up a bit? Yeah, it's fine like that.
I can continue now.
Why are you multiplying by x cubed over 3?
Yeah.
Why are you multiplying by, no,
What?
the sum of,
Yeah.
after provided that?
Oh. I got this is this. I just simplified this. Then this is this. I just took it in front.
Yeah.
Yeah. Can I continue?
Can you please explain again why you multiplied with x cubed over 3?
Oh, saying, oh, But you see this one, you understand this one, right?
No, I don't.
I get it. I dropped this from here. I dropped this from here. You see, right? For us to have this one here. And then I factored out 3 here on the denominator for us to have this one. You see, right? And then I had this. Then I took out this 3 outside and it's in the denominator, so it's gonna come out to be like this. You see? And then from there, I changed this to the summation. For me to change this to the summation, I only take this and put it inside here to the end. One.
Okay.
And then I say provided, take this. Then I want to simplify now. I can just take this and multiply here. So this is the same thing. I just wanted to take this and put it in front somewhere here. One. Because it's multiplication, it's commutative. So I keep the base and add the exponents. Also this one, keep the base, add the exponents. One.
Okay, I understand.
Alright. So the second question that we have now, we have f of x is equals to 3x squared over 5 minus 2 cubic root of x. And then we know we must change this to what? 1 over 1 minus x, provided that the absolute value of x is less than 1. We agree, right? That means that we must drop 3x squared. One over 5 minus 2 cubic root of x, because we need 1 here. You see, right? So we'll drop that, and we need 1 here, so we factor out that 5. So we factor out the 5. We factor out the 5. Then we check out the 5. You see, right? Provided, no, not provided yet. Let me put it in that format. Then I can provide that. Provided that we have cubic root of x over 5 to the n. So we provided, take this. You see, right? Then I can simplify this. So you see that if I summarize this, I can have and this will be, so I can put this together and say, don't forget, this is the same thing as having, you see, right? So here I can have 3x. I think I can have, that's fine. Let me just have x alone. Let me just separate them one by one so that you can see. So this will be, do you have n with 3? I think I don't have n with 3. It's fine. I can just keep this 3 over 5 times 2 to the n over 5 to the n. So I think this way I can keep them together. And plus 1. This 2 times 2 to the n. Then this one it's times x n over 3 plus this 2. Yeah, so let me put them together. So this will be 2 to the n over 5n plus 1 times x to the n over 3 plus 2. Yeah, so this is the simplified one, right? Then it means that you can still put it anyhow, it's fine. Some could decide to put it like this. Some could decide to say this will be the summation. You can put it anyhow.
Sorry.
Yeah?
How did you get n over 3 plus 2? Where does that 2 come from?
Which 2?
More x to the power n over 3 plus 2.
Then the 2's coming here.
Okay. Okay.
If I keep the base and add the exponents. So you can still put it anyhow. Someone could decide to put it like this. Right, you can still put it anyhow. But for the interval of convergence, we know that we're supposed to take this 2 over 5 times x to the 1 over 3 plus 1, which this would imply that we have x to the 1 over 3 absolute values, which is less than 5 over 2. This would be means that for us to cancel that, we must square both or cube both sides. What will be the answer to this if we cube both sides? 5 to the third is 125, right? And then 2 to the 8. So this is the interval of convergence. Is it right?
Like, Matimba, can you please go up? I want to ask something. Oh, like here, second last step, ne? Like, yes, like how did you get 2 over 5x to the power 1 over, no, not Kolan, like, lang was like blue.
This one?
No, that was like just after the black pen, like like blue.
Yeah.
Like, yeah, like how did you get 2 over 5 x to the power of 1 over 3, like from all these things that were here?
No, it was this one. We always get it here after plugging you see the moment after changing this? It's this thing. You say provided that this is less than 1.
Okay.
Then from there, whatever you do, I was just trying to simplify this. You can just simplify it going down. Then when I want to check the interval, I'm just gonna take this. You see?
Oh, okay, yeah, I understand. I look maybe if they can like these things.
Oh yeah.
Sure.
So are we fine?
No, I'm not fine.
Which part?
I'm telling you, I wanna more the absolute value of x to the power a third, ne? So isn't that something we cube Eliana? I mean the cube root to get rid of.
Yeah, you should. That's why I didn't write it here.
Okay, but then okay, never mind, it's fine.
Sure. So it means that now we can continue, right?
Yeah, we can.
Alright. So now we come to this one. We are given f of x, actually g of x is equals to, we have 5x over 1 minus 3x to the 5. Then now let's do this. Now we say that this will be equals to, let's say we're going to drop, right? Obviously we know that here we would need 1 over minus x, provided that the absolute value of x is less than 1. So we would have 1 over 1 minus 3x to the 5. We agree there, right now? Do you agree? So this would be 5x, the summation of infinity, n equals to 0 of 3x to the 5 n, right? And then this would be provided, you see, after putting that in that format, you must write provided the absolute value of 3x to the 5 is less than 1. So now from here we can simplify this. So this will be equals to x to the, yeah, but we can do anything, x to the someone can decide to put it like this, or someone decides to put it like this. Anything is fine. Yeah, it would be something like this. Someone could decide to put it like this, which would be fine also. So it's the same thing. So this if we find this, we can put it in this format, right? So this will be fine. But then we could also do this by saying that we are putting the representation for the derivative of this function. So we could also do this by doing that, right? We can say this. Let me write. The derivative of this function would be, let me say, sometimes they can tell you to put it by the derivative of this function. So which means that rule B, you take this, but this one I don't think it's part of your scope, right? Because the only ones which are part of your scope, yeah, I think with this one we should just end here. Let me not add things which are not part of the scope. The other ones which would be part of your scope is if you ask yourself, if I derive this, can it cancel this? You say right. But in this case, we realize that x to the 4 won't cancel x. There will be a remainder. So we don't want to use the derivative part. So, but if the question comes, right? If the question says, if the question says that give a power series representation for the derivative of the following function. It means that after finding this, right, you should, after finding this summation, after finding that summation, you should come and say g prime x is equals, because we want to find the representation of the derivative of this function, and the derivative of this function we know it will be derived to something else, right? But we don't want to derive it, so you can easily find the representation of this, and then you derive the representation. Then we come to the representation, we derive it. So this will be equals to the derivative of the summation. This equals to this 5 minus 3 to the n and then we have x to the 5n plus 1 close, and then we derive this. So notice that this will be 5. I drop this. If I use power, these are constants, right? So I'm gonna keep them. I drop 5n plus 1. Then I keep this 3 to the n, and I subtract 1 on that x. It's 5 to the n. Do you agree? So I just derived this only because the other ones are constants. This one is kept constant, I derive that. If I derive that, I'll get 5n plus 1. I subtract 1 here, I'm left with 5n to the exponent. You see, right? So this will be the case. Any question? Any question? So it means that if there's no question, we're fine. So now let's come to this one question. Let's say now we're told, they tell us that we should find a power series representation. So we should find a representation for the following. Function and determine the radius of convergence. You see, right? And the function is as follows. We say that g of x is equals to 1 over 1 minus x squared. So we know that we should put this in this format, 1 over 1 minus x, provided that the absolute value of x is less than 1. You see, right? So now if we look at this function, obviously on the top we have on the numerator we have 1, but the denominator we have 1 minus to the all squared. You see, right? So it won't be simple for us to get rid of that squared. The only way we could get rid of that squared is if we, let me say, if we integrate. You see, right? Let me show you something. If I integrate 1 over x minus not x minus 1 minus x squared dx, this would be, I let the inside be u if I want, so I can let the inside be u. Let me use u substitution, and let me not use other things. Let me just use u substitution. du is equals to minus dx, which means that dx is equals to minus u, so u minus du, and this will be 1 over u squared minus du. This will be equals to minus integral of u minus squared du, and this would be minus 2 plus 1 over minus 2 plus 1. Obviously the integral goes with c, right? So if we integrate this, we get this, the negative, get minus u minus 1 over minus 1. This is 1 minus x minus 1, which is equals to 1 over 1 minus x. You see that if we integrate, we would be able to take this back to this format, right? So we realize this, but as we don't want to do this, this is just us checking, okay, how can I change this to this format? We can integrate, but we're not going to write integral here. We write the opposite. What is the opposite of integral? It's derivative. It's like we're moving from here back to that. You said it's like we're moving from here to here. So we must derivate. We must do the opposite. We know the opposite of this is what? So it means that from here, we know that we got what there? We got 1 over this, right? Is that. So we can just put d over dx here of that function which we got there when we're integrating. When after the answer we got there, when we integrated, we got 1 over 1 minus x. Then we know that the summation of this, the representation of this is this. X to the n. You see, right? So we can easily derive that x to the n. We would get n x to the n minus 1. You see, right? So provided that the absolute value of x is less than 1, which means that the radius of convergence is r equals 1. You see, right? That question is as simple as that. Any question?
Do we always start with integrating, then differentiate, or there'll be questions where we start by differentiating, then we integrate?
Yeah, it depends on. I think the first question is, how can I change this to this? You see, right now? And you realize that for the only way to change that to this is if you remove the 2. And so you can ask yourself 2 questions after that. Can I integrate or derive for me to change this to that? You see, right there, to get rid of this 2. So if I derive, that 2 will increase to 3. You agree with what's this, with quotient rule, right? We'll square the denominator. It will increase to 4. You see, right? So it means that the best way to solve this is if we integrate. If we integrate, I try to integrate, I realize that I got here. So I'm not going to write integration. That one, you just check it. You just use integration to check where you're going to get to. So the thing that you get to, you'll take it and write it here. You see, right? If you can't drop anything or subtract, if you can't use these methods, these are the simplest that we're using here. But if you can't use these, then that's what you do. You might as well, for this one, if you saw some question somewhere, you can bring it and then I apply the same thing, theory I show you. Now we can do this one. Let's say, yeah, let's do another one, then we see what I mean. Now another question that we have here is this. We have h of x is equals to ln of 5 minus x. Check this. I must change this, right? I should change this to 1 over 1 minus x. But can I integrate this? Can this question be integrated? No. You see, right? So the only way I can do that is by deriving. So what I'm gonna do now, let me just derive this. I wanna show you something. This is just like, this is me checking. You see, right? Then when I derive this, I'll get, you see, right, times the derivative of the inside. This will be See what did I get? I got minus 1 over 5 minus x. What I do, I'll take that what I got. It's like you'll be doing it somewhere, maybe on your question paper with a pencil. You see that? I take that. I derived. Remember, I derived to get that, right? So now I'm going to do the opposite. I'm going to take this and put it inside an integral. You see, right? I take that, put it inside an integral, and then I start solving that. So you know that this, for us to put it in that representation, we need to factor out 5 here. Then I can take out that minus 1 over 5. Let me do this. You see that? When I change this representation, I get this. You see that? Then now I can separate that so I can integrate the x. Then I can take out that minus 1 over 5 and plus 1. The integral of this will be nx, not nx, that one is a derivative, x to the n plus 1 over n plus 1, c plus c. Right, so this will be, I can start with c, say subtract, then I take that constant inside if I want, x to the n plus 1 over, I put this on the denominator, 5n plus 1 n plus 1. Is it right? Then now I need to solve for c. So for me to find the c, I can let x be equals to 0. You see, right? Always you have to let x be equals to 0. And then remember, this side it's ln of 5 minus x. You see? And then I'll come there and say this is ln of 5 minus 0, which is equals to c minus the summation n equals to 0, 0 n plus 1, 5 to the n plus 1, n plus 1. So this will be 0, this whole thing. So it means that therefore c will be equals to ln 5. You see, right? Then I can go back now and plug. Now I know that the representation of ln 5 minus x is equals to ln 5 minus the summation infinity n equals to 0. That's what there. X to the n over 5 to the n plus 1 times n plus 1. You see, right? Then that is the representation. And then they say that we should find the radius. We agree, right? So for us to find the radius, check something here. You see, right? You see this? Check this is what? X to the n plus 1 over 5 n plus 1. So it means that provided we have x over 5 less than 1. You see, right? So this would imply that the absolute value of x is less than 5. Hence the radius of convergence, right? R is equals to 5. Any question? Do you have any question? Now we can come to Taylor series, right? If we have any question, we can come to Taylor series. So now when we come to Taylor series, we can have this. We can say this. We can say that. So let's assume that if we are provided a power series representation let me say for the function f of x about x is equals to 0, then there will exist a Taylor series for f of x about x equals a, and that is like this. If we have f of x is equals to what this definition says, it says this. We're going to have fn a all over and factorial terms that about a. You see, right? This is the series about a, and I said that last time. Remember, I said that if we expand it, we're going to have f0, plug 0 and n first. We have f of a plus we plug now we come to the second one, so this is like this. So if we come to the second one, we're going to have a x minus a. So plug 1 here, 1 right, plus f, now it's all for 2x minus a squared all over 2 factorial, see, plus f to the third a x minus a third over 3 factorial up until like that. You see, right? So this is the Taylor series. Now let's say now this is now if x is equals to or not x, if a is equals to 0, now we'll have the Maclaurin series, right? If a is equals to 0, which means meaning x is equals to 0. Remember, initially x is equals to a. So if a is 0, it means that x is equals to 0. So we will have Maclaurin series. But if it's any number, so it won't be Maclaurin series, right? If it's any number other than 0, it can be 4 or something else, is Taylor series. Or if it's any number other than that, then won't have it. Remember, for the Taylor series, we had this. We had a and factorial x minus a to the n. So if a is 0 now, you see, right? If a is 0, it means that that will go, we'll have to the n, and this a will become 0 here. You see, right? This will be the Maclaurin series, and this will be equals to f of a, your f of 0, which is f of a is 0, don't forget, 1, then we're going to have 0 over 1 factorial. I can write 1 factorial x to the n. So n is 1, which that will become x, plus f second 0 x squared over 2 factorial, plus f1 to 3 0 x to the 3 over 3 factorial. You see, right? Then this would occur until. So now this is our Maclaurin series, right? Now I think someone said that you guys did what you call the nth degree Taylor polynomial. So what the nth degree Taylor polynomial does is that it determines it's used to determine a condition that must be true, right, in order for a Taylor series to exist. So we'll see if we can have questions on this one. So if we have the nth degree of Taylor polynomial. So let me write here. So this is to determine condition that must be true. This should be true in order for a Taylor series to exist. Is that right? So, or to exist for a function. You see, right? So this is given by Tnx is equal to the summation n 0 of f I a over I factorial, then we have x minus a I. So it's simple, right? Remember the Taylor series here, it had infinity, here it had n. So you just come, remove the n, you put I, remove the infinity, you put n. So that will be the nth degree Taylor polynomial of f of x, right? So now if we so it means that now let me do this. We also have this one as well as the nth degree Taylor polynomial, right? Then let me just write the other one, then we can see. And we also have the remainder. So for the remainder, the formula for the remainder says that we have Rnx is equal to our function minus the nth degree Taylor polynomial of f of x. So now it means that we can now see if we can have questions or not, right? That we can use to prove this. So I don't know, did you guys do any theorems based on this Taylor series? Did you guys do any theorem?
Taylor theorem remainder.
We did what? Or the Taylor
Wait,
theorem?
let me check.
The one of saying f of x is equal to, is it Tnx plus Rnx. where it talks about the limit of the remainder.
The Taylor theorem remaining.
The one that talks about the limit of the remainder. All right. Yeah, please send the theorem there to me, then we'll do it tomorrow. If you did it, it might come. Because here we have very less theorems and yeah. So, now let's come to questions, right? We have the first question, which they say that we should find the Taylor series for the first one is f of x is equals to e to the x about x equals to 0. So already if x is equals to 0, it means that we're dealing with what here? We're dealing with Maclaurin series, right? So even though they said find the Taylor series for this, we're dealing with Maclaurin series. Do you agree with that?
So like every time x is equals to 0, it means we are dealing with the other one.
Yeah. And the equation for the Maclaurin series says this. It says that, let me just write, so the equation for that, it says this, the summation of n, the n 0 over n factorial x to the n. We agree, right? So it means that we can expand this and have f of 0 plus prime 0 x plus f second prime 0 x squared over 2 factorial plus f3. If you write the number, you must put it inside brackets, right? 0 x3 over 3 factorial plus f4 x to the 4 over 4 factorial up until. It means that if we see dot dot dot, it means that this must end at infinity, right? That one already ends at infinity, so that's why we put dot dot. Then we realize that we need this. We realize that we need f0, we need f this, right? So we are going to write them. So first we must write the formula. There is a mark. So first we're going to write f of 0, not f of 0, we need f of x first. Our f of x is equals to e to the x. Then we can write f of 0 to be equals to e to the 0, which is 1. You see, right? And then we have f of f prime. This remains the same. You see, right? Of 0, which is e to the 0 plus 1. F second prime remains the same. 0 equals e to the 0 equals 1. So we realize that this will occur up until f of n, which should remain the same. We'll put brackets because that will be a number, right? Then we'll say that fn 0 was e to the equals 1. You see, right? So this, if I go back and plug it there, I'm going to have f of x being equals to f of 0 is what is 1, so that is 1 plus f of f prime. First f prime is 1, then I'll just have plus x squared over 2 plus x 3 over 3. I'm plugging here, right? And here, not 3, this one is 2 factorial, 3 factorial plus x to the 4 factorial plus those. So if we check the format here, if we check the format here, we are having what? X squared. So this is the same as x to the 0. So already we have x to the 0, 1, 2, 3. So that is like x to the n, because even here our thing starts at 0. Then below we have 2 factorial, 3 factorial, 4 factorial. This one is 1 factorial here, and here it's 0 factorial. So it means that this will be over n factorial. You see, right? Then that will be our representation for e to the x. So don't forget f of x equals to e to the x. Then that will be the representation. Any question? Any question? So you see the format, right? So yeah. So now let's do the second question. So can we do the second question? We're all fine, right? And then now we have for b, we have that f of x is equals to e to the minus x, right? About x equals to 0. So it means that if it's about x equals to 0, this is Maclaurin series, we know. This is Maclaurin series. So might as well come and say this is Maclaurin series. Would be like this. So I know I need f0, f prime 0, all that, right? So with f0, I'll start with f of x is equals to e to the minus x, and f of 0 will be e to the minus 0, which is equals to 1. Then we have f prime of x, which is equals to minus e to the minus x. Then f prime of 0 minus e to the minus 0, which is equals to minus 1. We have f second prime of x is equals to e to the x. F second prime of 0 is equals to e to the 0, which is equals to 1. This, now the third one, minus e to the minus x of 0 equals to e to the 0 minus 1. This would occur up until we get to f to the n of x should be equals to minus 1 to the n e to the minus x. The reason why I have minus 1 to the n is because you see this thing alternates. You see, right? Positive minus, positive minus. So it means that f to the n of a 0 would be equals to minus 1 to the n, because this one will always be 1. You see, right? So now let's go back and plug. Now this means that f of x will be equals to f0. We know that it's 1, right? It's 1. Then f prime 0 is minus 1x, so it's minus x plus x squared over 2 factorial minus x3 over 3 factorial plus x4 over 4 factorial up until, you see, right? So this would occur like this up until the end. So it means that we know that this will be equals to, you know, this is e to the minus x, the summation infinity, and equals to 0. We know that once this is alternating, right? Let's say you didn't know this, right? Let's say this is alternating and this starts from positive 1. Already we know if it's alternating, we need -1 inside. So on the top, we'll decide if this starts from 0 and this is 1, it's positive, right? So if I put n, it will be satisfied. So the other ones is x to the n. You see, right? Then the numerator is x to the 0, x to the 1, x to the 2, x to the 3. Then the denominator is 1 factorial, 0 factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial, and so on. So this is n factorial. You see, right? That means that this will be the representation for this. Any question? Any question? So I will find. So if we are fine, let me do this. Try this. If you do this today, trust me, you'll be set. If you do this by tonight, you'll be fine. Then the last one. You know, I'm writing a lot of them because they have different types of derivatives, right? That you can familiarize yourself with. So that if they bring any type of derivative, you already know what's happening. You see, right? So I hope that is fine. So the solutions, let me give you a hint. Yeah, so I hope we're fine here. So please try this. I think there are how many? 1, 2, 3, 4, 5, 6, 7. If you can try this, you'll be fine. And then yeah. So any question?
Can
Can you please scroll down? I want to see the hint part.
Then a bonus question. Let's say for the bonus question, determine. So tomorrow we're going back to infinite series, right? So yeah, Taylor series about x equals to 0 for the following integral. And then I can tell you that the solution for this is yeah. So we're going to